Good morning. This key begins with number 6 from the worksheet that you see in front of you, and so that you can see the rest of it. And then page 2, so then start with number 6. 6 to 13 are asking you to solve equations. What you need to be careful of whenever you solve quadratics, you've got to have them equal to 0. So this needs to be moved to the other side. The first thing you always want to do is factor if you can. Pull a GCF out first, and by pulling a GCF out, this can't be factored anymore. The 0 property allows us to set each factor equal to 0, and then we solve each one, and when you circle it, that's your answer. Don't forget, this is equal to 0 here, equal to 0 here. This allows you to use the 0 property here. So remember to keep those equal signs and the zeros, keep it nice and clean. Show how to solve each of these individual factors equal to 0. For the next one, you have the option of either using the square root method or factoring it, and you can see both of them there. For number 8, the issue is that it's not equal to 0, so you've got to expand the left-hand side, subtract 14 to bring it over, recollect all the terms, and then go ahead and factor 0 property and solve. For 9, you have two options for this one. You can factor this, or you can go ahead and use the square root method, as you can see here. For number 10, for this one, you can expand the left-hand side, subtract the 25, and factor on go along your happy way. Or, since it's already this guy squared equals 25, which is a 5 times 5 or negative 5 times negative 5, we just take the square root of both sides. When you do that, you get plus or minus the square root of 25. Bring that 2 over by adding 2. This looks really weird. Don't worry about it. Square root of 25 is 5. This is saying 2 plus 5 and 2 minus 5. So you get two separate answers for this one. For number 11, you've got two options again for this one. You can add 16 to both sides, and if you add 16 to both sides, you can use the square root method, or go ahead and expand this, collect like terms, then factor and 0 properties. So your choice. So you are getting options at this point. Remember, not everything is going to be factorable. When you get to the next one, again, same issue, take the 12 over, factor, and on your way. Now for number 13, you do that, but this guy is not factorable, so you have to use the quadratic formula. Remember that the inside is the radicand is b squared minus 4ac. Remember, you do need to memorize the quadratic formula. The best way to keep your answers from having any little errors floating in is to write your a, b, and c here. Go ahead and calculate b squared minus 4ac. Then take that number that's the radicand and put it inside that radical. Then go ahead from there and get your two answers. Remember, if you get to this point and this is a negative number, then it would be the square root of a negative, which gives you no real solutions. When we look at number 14, this is giving us a function, and we have to determine where the vertex is, the axis of symmetry, the y-intercepts, all of the different characteristics. I'll just give you some reminders. And so it's facing up because the leading coefficient, and the leading coefficient here is the coefficient of the x squared term. And so that's positive, so it's up. The vertex, you get negative b over 2a, and then substitute that into the function to get the y value. You need both an x and y coordinate for your vertex. Axis of symmetry is always x equals, and it's going to equal the coordinate of the vertex. Y-intercept, you got to go find it. And x-intercept, set your function that you were given equal to 0, and solve that in any way that you can, and then that will give you your two intercepts. At that point, go ahead and graph it, and then you can answer questions about domain, range, and then increasing and decreasing. The range is going to include the y value of the vertex, and we use a bracket because it does include it. So make sure you have a bracket on that for your range. H and I are increasing and decreasing. You always use parentheses because you can't be increasing or decreasing at an endpoint of an interval. For number 15, you're given a quadratic and you're asked, without graphing, to decide if it has a min or maximum value. So for this guy, go ahead and find the vertex and the y value of the vertex. And we know that this is facing down. Is it facing down, or sorry, it's facing up because it's a positive, I'm sorry. It's facing up, and because of that, you get a min value down here at the bottom. I usually draw a picture, so it's weird that there's no picture sitting here. I usually say, okay, it's facing up because the y value, the coefficient here is positive. That gives you a minimum then, and it's a minimum value of whatever the y-coordinate is, and it occurs at x's, whatever the x-coordinate is. 16 you'll see on the next page because it's a little longer than the space provided here. For 17, you have to find the vertex and then algebraically find the x-intercepts. We've done that before. For 18, find the dimensions of a rectangle, and they give you a perimeter and area. So go ahead and set up the two equations that you know. It's going to be 2x plus 2y is 26, xy is 40, because that's how you find area and perimeter of a rectangle. Then solve the one equation for one variable and then substitute it into the other equation. This is a system of linear equations sorry, it's not, this guy is not linear, system of equations, and with that you can use multiple techniques. One of them is going to be substitution like this, and the other one we will cover later because we're usually going to use substitution. 19, oh here we go, 16, back to 16. You're given a vertex and a point, and you have to come up with an equation of a quadratic and find that a, b, and c. So we know that the vertex is negative b over 2a, so set that up and set it equal to 1, which is the x-coordinate of the vertex. Solve that for one of the variables. It doesn't matter which one. I solved it for b. Then use what you know, which is a 0.13 is on this equation. Here, if we graphed our function, when we know a, b, and c, our 0.13 is on that equation. So let's go ahead and put the y in for 3, the 1 in for the x's. Remember, b is negative 2a, which is where this guy's coming from. This allows you then to get an expression for c. So now we have an expression for b, as an expression for c, and we can take both of those and substitute those into our function. So we have ax squared, b is negative 2a, c is a plus 3. Then use the negative 1, negative 8 point. You put negative 8 in for y, and then for each of these x's you put a negative 1 in, and then go ahead and solve, and you get a. Once you have a, you're going to go back up here and find c, and then take the expression for b that was up here and substitute that in again. We call that back substitution, and it allows you to find then each of the variables a, b, and c, and now that we have those numbers, we just substitute those in here, and you are done. For number 19, they're giving you the daily revenue function. They're giving you a cost function with x being the boxes, selling so many boxes of candy. And the first question is asking us, find how many boxes to maximize the revenue. Okay, so we need to maximize the revenue, which means we need the x-coordinate of the vertex because we want to know how many boxes. Revenue is given to us. The vertex, remember, negative b over 2a, just pull them off of here. This is in a different order. The a is here, this is the b, so be careful of that. You may want to put it in descending order so you get the a and b correct. And that gives you how many boxes. Go ahead and round that. You need about, and use the little tilde guy, about 119 boxes. What's the max revenue? Then you take the number of boxes that you have and substitute it back into the revenue function, and it's going to be about $564. Now for the third part, we want to know what profit is. Find the profit function. Profit is revenue minus cost. And so we just write the revenue function minus the cost function, use parentheses, then distribute the negative sign because otherwise you're going to lose this sign. So here's our profit function. Now we want to know how many boxes of candy must the firm sell to maximize the profit. So we need the max profit, and how many boxes need to be sold, so we need the x coordinate. Again, we're going to use negative b over 2a. This is already in descending order, and so we pull off the b and the a, throw it in, and get a value. So rounding, we get about 103 boxes to maximize the profit. The next question is, what is the maximum profit? You just substitute that 103 back into the profit function, which is what you see here. Substitute it in and calculate it, so you get about $175.39. For number 20, there's the annual fixed cost of owning a car. And costs are variable cost plus fixed cost. So they tell us the fixed cost, $14.59, and the variable, they tell us it's 0.25 cents a mile, and x is the number of miles. Now they want us to write a linear equation that equates the cost to the number of miles. So we just write, there's our variable here, and here's our constant, and then you're done. That's it. There is no work other than that. For the second part, they want to know, if you drive 15,000 miles, how much money is it going to cost you? And so remember, x is the number of miles. You just evaluate the function at 15,000 to get this final answer. For number 21, electricity is measured in kilowatt hours. Make sure we see the whole problem here. Is measured in kilowatt hours. The rate of electricity multiplied by the time that it's used. For example, if you have a 100-watt bulb left for 20 hours, it'll use 2,000 watt hours or 2 kilowatt hours. And our first question is, our first question is, the average light bulb is turned on for about 3.13 hours per day. If you have 20 100-watt light bulbs, how much electricity in kilowatt hours do those bulbs use? And so total watt used is going to be the number of hours times the number of watt bulbs, whatever watt the bulb is. We have 100 watts. And then how many days in a month. And so how many hours? 3.3 hours per day. 100 watts, how many days? 30 days. That unit divides out and we get watt hours from this. So we have 9,390 watt hours. Remember, we have to do the conversion to kilowatt hours, so we're moving the decimal place over 3 places. How much are you saving if you replace your bulbs with compact fluorescent bulbs? And so this goes beyond the idea of you being able to save the planet by using more sustainable materials, using less electricity as a whole. And so your amount saved is going to be the amount you were using, which came from the previous problem. And now they're changing this here. This is what's different with the other equation from above and here, is that this is only using 26 watts, so the bulbs use less watts to give you the same amount of light. And multiply them out, subtract the two, and you end up with how many kilowatt hours you have saved. Remember, this is a watt hour converted to kilowatt hours. For number 22, you've got an electric company charging so much money per month, $10.45, and then they have a variable cost, and the variable cost, lost my place on the worksheet, the variable cost is 9.75 cents, which is written like this. And so what we have to do then is write a linear equation. That's that. For the next one, you use 650 kilowatt hours. How much is that going to cost you? All you do is substitute in the 650. And then for C, suppose he switches them out with 26 watt CFLs. And so this is just like the previous problem where you substitute that in and get that difference in cost. So for number 23, this is a texting question and a cell phone bill, which is interesting given today's texting and unlimited calls. This is more of an old school problem. And so they tell you how many texts and what the phone bill was. So we get 2 of them, so we're going to go ahead and make 2 ordered pairs. Once you have the ordered pairs from the number of texts and comma the price of the phone bill, you can then find the slope and create a linear equation that will give you a function that will predict the amount of her bill based on the number of text messages. So then B, if she sends 1,000 text messages, then you just substitute the 1,000 in here. This would be her bill. And find the p-intercept. The p-intercept is going to be what happens when you send no texts. You're still charged this. So sending 0 texts is going to cost you this much money. Jump down to the last question, 24. You have an immunization advocacy group. 5 million is spent and the mortality rate is 0.5%. If 10 million is spent, the rate goes down to 0.3%. So they give you this information. We make them ordered pairs. Do the conversion from the percentages to make them decimals before you find your slope. Go ahead and find your slope, find your equation. You now have a function, a linear model for the infant mortality rate from pertussis as a function of the amount of money spent on an awareness campaign. Once you have that function, we can decide what the intercepts are, the m-intercept and the a-intercept. And so remember, when we set up our points, we put the amount spent and then we put the rate, where m is for mortality rate. So the m-intercept for this, we set the other one equal to 0. So what is, take your function that is here and put 0 in for a, and you get 0.007. So when they're asking you to make the a 0, they're saying you are spending no money on the awareness campaign. And if you spend no money, then the mortality rate actually goes up to 0.7%. What's the a-intercept? You set the other one equal to 0, so we're going to set m equal to 0, so this function gets set equal to 0. Go ahead and solve for a, and so they're saying that with the model that we created, if you spend 17.5 million, the mortality rate will be 0%. Now the reality is, as we understand it, this is a data problem. You have 2 data points. This is a predictor equation. And the sad reality is that there will never be a 0% mortality rate for pertussis unless we are allowed or able to eradicate that disease. So the model is predicting this, but we do know in reality that it will not reach 0%. So hope you are having a tremendous day. That's it. Take care.